Should I use pi r squared or 2 pi r? Can someone raise your hand and tell me why? Yeah.
2 pi r.
Why?
Because that's circumference.
Oh, circumference is like length? Oh, okay. Okay, so we're going to go ahead and use the circumference. How would I know to use pi r squared? Mary? So if I ask for the area, okay, that's when I use the area formula. Okay, I think I got it straight now. Here's the formula. Now I just plug in information that I know. I know the length of TV is 15 pi, so I'm going to go ahead and say 15 pi equals, I know the degree measure of the arc, which is 150 over 360 degrees. Good, good, good. I know 2, I have pi. I shouldn't put an equal sign. I don't know where that came from. Let's change it to a multiplication sign. I have 2 pi. I don't know r. That's what I need to solve for. Hey, wait a minute. This is a number. Everything's a number except for r. So I can let my calculator do this work. I can just go, hey, 150 divided by 360 times 2. And then go 15 divided by whatever that number is, because our pi's are going to cancel out. And r is going to equal 15,021.6.
Yeah.
Yeah.
That's what I got.
Is that what everyone got?
Yeah.
It's 18.
Let's go.
The answer should be 18. What? That's a huge radius. No, it should be 18. You had it right. Okay. Does that make sense? All those made sense? Okay. This is something you need to know for the test on Tuesday. All right? We have problems that look just like this. Before we get started, I want to talk about an email I sent out. I sent an email to all of you. It's a survey that you need to take about this class. The whole math department has to send out emails to all their classes. The actual link doesn't work. I guess if you click on it, it doesn't work. So you have two options. Copy it and paste it in your browser, that bar up on the top. Or you go to Edmodo, and the link is posted right there. You just click on it if you don't want to copy paste. All right. If you could, please take it sooner rather than later, because they're waiting for those results. Okay? Your name's not attached to it, so be honest. All right? So there's no brown nosing either. Like, Mr. Pavman's the best ever. Please increase my score. No names are attached to it, so be honest. And only take it once. Okay? Just take it once. I don't need to have 1,500 surveys taken by Alec. Just say, terrible, terrible. Okay? So sooner rather than later, whenever you get to it. It's super short. Who's taken it already? Did someone? Yeah. It's really short, isn't it? It's like 9 questions, and they're all from like least likely to most.
Yeah.
All right. So nothing hard. Okay. Like I said, we don't have the test until Tuesday, so it gives us the opportunity to talk about that homework that we did yesterday because it was a step up, right? Mm-hmm. It has some tough questions. What I'm going to do is I'm going to go through the ones that are most likely going to be on the test. And unfortunately, it's all the ones that are colored. Those are fair game. But hang on. Once I go through one of them, I go through another one, you're going to see there's a nice pattern, and you can actually figure it out doing that. So we're going to go ahead and start at 24. I'm going to warn you right now, we're not going to get to today's lesson. Lots of sad faces, right? No, sad faces. At least pretend like you're sad.
Wait, what?
We're not going to get to today's lesson, which means tonight we won't have homework.
Let's go.
But that doesn't mean we don't have homework.
Wait.
It's going to be on your own homework. It is, we go over these questions. You go home tonight and make sure you understand them and you try them again on your own. Okay? That way you know, hey, next Tuesday I can do these problems. Or tonight you try them on your own, you're just like, you know, some days when you get home it's just like a completely different problem, even though it's the same, where you just don't know what I did. Then it's a good idea then tomorrow or on Friday asking questions about it. Okay, so we're going to start at 24. I'm going to need just a little bit of help just in case I make, not a mistake, I will make mistakes, I'm sure of it. But I just want to make sure I got the questions right. I think A is 1 to 3. Thank you. That's exactly what I need. So we're going 1 to 3. So our 3 questions are always going to be, are they similar? Do they have the same height? Do they have the same base? Good thing is if they're similar, we stop at 1. So my question is, are 1 and 3 similar?
Yes.
Yes, they are. Yep. And I'll give you a hint. On these problems, if they don't have the same height or the same base, they're most likely going to be similar, right? I'm not going to give you some oddball that, haha, you can't actually solve it. So it's going to be one of those 3, just got to figure out which one it is. Their bases aren't the same, their heights aren't the same, so it must be that they're similar. So 1 to 3 is dealing with similar triangles. Okay. To use similar triangles, I have to go from a scale factor and I have to go from scale factor 2 to get to my area ratio. Can someone tell me how to get to scale factor from 1 to 3? Who haven't I talked to? Lauren, did I talk to you already? We'll just say no. What is?
So you, since they're both based are 5 to 10,
Mm-hmm.
the ratio of their base is 5 to 10.
Yep.
So the scale factor is 1.
I had a great question. So it's 5 to 10, which is 1 over 2, right? Or 1 to 2. I had a great question. Are you allowed to go 5 to 10, which equals 1 to 2? Absolutely, you can write that like that. You don't have to write it like I do. I typically treat it as fractions because it makes a little more sense in my head. So I always use fractions. I do 5 to 10, which is going to be equal to 1/2. So that is our scale factor. Does that mean our area ratio is 1 to 2 too then? Because I just have an arrow there, so I'm good. Boom. Area ratio 1 to 2. Nailed it.
No.
I said nailed it.
You think
Oh. What do I need to do? Someone raise your hand and tell me what I need to do. Yeah, no.
squared also kind
I have to square the top and bottom. So it's going to be 1 squared over 2 squared. 1 squared is 1. 2 squared is 4. Our area ratio is 1 to 4. That's what I was looking for. The problem says, what's the area ratio between 1 and 3? It is 1 to 4. That is one of my area ratios. Done. Move on to B. B is 1 to 2? Is it 1 to 2?
C.
Yes.
Alright, so now I'm going to ask myself 1 to 2. 1 to 2. Are they similar?
No.
No. Do they share the same base?
No.
Are they the same height?
No.
Yes.
How?
This is 1 and 2, right? So if I draw a height down,
Oh,
they both have that same height.
so complicated.
Hey, just go through your checklist. It's going to be one of them. Alright, so so if you get stuck on the test, these obviously don't have the same base, right?
I can't rotate my computer.
And they're obviously not similar, so through process elimination, for this section we're just going to know that it must be the same height and just figure out how it's the same height.
Got it.
Okay, so we're going 1 to 2, same height, that means I'm comparing bases. So they're the same height, we're comparing bases. Ugh. What's the base of, what's this length? Can we take out a ruler and measure it? Yes. And then we get it wrong. And I don't know, okay, so I don't have any numbers. Yeah.
The ratio of 1 to 3 for areas, 1 to 4. Or like, the scale factor is 1 to 2.
I got you.
It's like the same size for like the bases. The ratio is still 1 to 2.
Yeah, absolutely. So I can't do anything here. I'll walk through that. I can't do anything here because I don't have those lengths. So I'm going to go back to this 1, 2, 3. And I am just going to look at triangle 1 and 3 just for a second. Let everything else kind of fade away. That was a bad erasing job because I want that line. So we're pretending like the whole world disappears except for a triangle. That's about as best as I can do. 1 and 3. Well, the scale factor is 1 to 2. So from here, I just double it, and I have this base. So although I don't know this length here, I don't know that length there, let's call it 1x. That would make this length over here 2x, because it's 1 to 2. And I would do the same thing for the other side. If this is 1x, this must be 2 times some number. Just like this is 1x to 2x. It just happened to be our x was 5, so it's 1, 5, that's 10. Do we get where I got these x's and these 1s? Because you kind of have to follow along with what I'm saying. Alec, you got those? Okay. So now let's go back. Oof, that's the problem with going back in time. It erases everything I did. So remember that this is 1x. That's 2x. This guy's 1x. And this is 2x. So that means the bases of 1 and 2 are that 1x and 2x. So the ratio between the two is this base ratio, which is 1 over 2. So we can write it as 1x to 2x, but it's much easier just to write it as 1 to 2. Does that make sense? Okay, then let's go on to C. I'm going to put C over here. C must be 1 to 4, huh? That is the area ratio. Yeah. Only in similar triangles do I square the top and bottom.
Gotcha.
All right? This is our area ratio because it's the same height, which is base to base. So base 1 over base 2 is my area ratio. Don't forget that. How easy would that be to miss on the test? How easy would it be to square this top and bottom if you're just kind of going? Very, very easy. So just think about it. Now, your checklist is similar triangles. If it's similar triangle, I have to square something. Everything else, you don't have to square it. Okay? All right, so we have the area ratio is base 1 over base 2. 1 and 4. 1 and 4, they're not similar. They don't have the same base, so it must be same height. That guy's same height. Oh yeah. Oh yeah. So now just look at their bases. One's base is 1x. Maybe I'll highlight the base. I think I forgot to do that. So let's highlight this base. So one of our bases is 1x. The other one is 2x. So it's 1x over 2x or just 1 over 2.
Whoa.
All right, now let's do D. D is a little trickier. That is 2 to 4. I don't have a ton of room. Luckily, it's kind of easy if you think about it.
It's the same.
It's the same. This is 2x over 2x, which equals 1 over 1. This is 1x over 1x. So our scale factor from 2 to 4 is just 1 over 1. Yeah, 1 to 1. Yeah. They are similar. Yeah, sorry. We should have went through that checklist, right? So they're similar, so we need to compare these, and it'd be 1 to 1, 1 squared over 1 squared is still 1 to 1.
Oh, okay.
So the scale factor and our area ratio is the same in that one. Thank you for bringing that up. All right, our very last problem is E. E is a little trickier. It says, do 1 compared to everything, the whole figure. Well, my scale factor, let's look at each of our scale factors. 1 to 3 is 1 to 4. 1 stood for 1, right? 4 stood for 3. This one's 1 to 2. 1 stood for here. This was 1 to 2. 1 stood for our small triangle. So when I have the whole figure, my area of figure 1 is going to be 1. Yeah.
For D, we can also know it's 1 to 1 because like the area ratio for C and B were the same, and like it's comparing 1 to.
Yep. So Lauren just said, I already knew that because this was 1 to 2. This is 1 to 2, so the ratios were the same. So if I compare something and I say this is twice as big, this is twice as big, those two things must be the same size. Yep. All right, so our 1 in every single one of these problems has been 1 on top. So we're going to leave 1 on top. That's our starting ratio. Now I want to compare it to every single shape we've already seen. So when I compared my area ratio from 1 to 3, I had 1 over 4. So we're just going to put a 4 down here. That takes care of segment 3. Segment 2 said it was 1 to 2, so we're just going to add a 2 on here. That will take care of segment 2. And finally, segment 4 is 1 to 2, so we're going to add another 2 in there. You going to say the thing I missed? What did I miss?
You missed 1.
I missed a 1. Lauren said I missed a 1. Who knows what 1 she's talking about? And in fact, she's figuratively saying 1 and literally saying 1. Jamie?
The 1 to 1.
I'm missing the 1 to 1. And it's not this 1 to 1. Because this is 2 to 4. I'm still going 1 to. I'm talking about, so this 4 took care of this. That's gone. The 2 took care of that one and that one. I didn't account for this shape.
Did the 4 count for the big one and then the 2 twos count?
Oh, I'm sorry. I have my hand the wrong way. Yeah. Let me just cover it up. Let me cover it up and see if it makes more sense. So the 4 took care of this triangle part of it. The 2's took care of this part. And this part, I never accounted for this. I need to add everything together, right? It's the total thing added together. Well, if my ratio is 1 up here, then this must just be 1 to 1. So we have to remember to add a 1 in there. And that's our answer. Jamie, does that make sense?
Not really.
Not really?
No, I get that you want to try and go up, but then I got very confused.
Okay. So let's bring everything back. Do we get where I got the 4, the 2, and the 2 from? Okay, so I need to compare 1 to this entire area. I need to compare it to this entire area. So I need to account for this triangle on the bottom as well. I need to account for this triangle on the bottom as well. So what's the ratio of this triangle to itself?
Oh.
What is the ratio of this triangle to itself? 1 to 1. So if I have 4 sections here, I need to have 4 additions down here to say, because if I have 4 parts, I have to add all 4 parts together to make a whole, right? Currently, I'm just adding 3 things. That 4th thing is that 1 to 1 ratio, so we need to add a 1 to it. Is that a little more clear?
The ratio 1 to 1 because you do 1 x over 1x. And
Well, the ratio is 1 to 1 because
oh my god.
it's the same figure, right? It's the same figure, so if I take one side, it must be equal to that exact same, because it's the same figure, right?
Yeah, sorry.
Oh, no, that's fine. As long as it's clear now.
Yeah.
Are we good on this side? Okay. So we're good on this problem? All right, now let's see problem, I think that's 25. I lost it.
Yeah.
We're going to see it's very much the same problem. Okay, it's very much the same problem. Lauren's giving me kind of the cockeyed, but yeah, kind of. There's a little tweak to this one, and as the numbers aren't as nice as the other one, and we'll see what I mean at the end. So help me through this one. All right, my A is 1, 2, 3. Similar, same base, height, everyone. Similar. So we have similar triangles. So if it's similar, I need a scale factor first. To get a scale factor, I just compare the two sides. I have 8 over 18, which is 4 over 9. They asked the area ratio. Can I just stop here? Do I really have to do the area ratio? Aren't they the same? Mary? Oh, I squared the top and the bottom. Okay, so I need to get the area ratio because it's a similar. Oh, that's right. If it's a similar triangles, I have to get the area ratio from the scale factor, which is I square the top and bottom, so that'd be 16 over 81. I'm going to shortcut this one because I can kind of see how it's going to go the same way as the other one. So our scale factor was 4 to 9. So if I look at triangle 1 and triangle 3, to get from here to that side would be basically 4x. And the other side would be 9x. And this would be 4x to 9x. And if we wanted to, we could label this as 4x. And this is 9x as well. But I already know those two values, so why take the time? All right, now we go to B. The busy B. That is 1 to 2. Someone raise your hand and tell me what I'm looking for. Similar, same base, same height.
Same height.
Thank you for raising your hand like I asked. So we're going to compare the bases. So we look at 1 and 2. Let me highlight our bases. I mean, I don't really need to because you should already know by now, but my highlighted bases, I'm looking at these two things. Well, the ratio between their bases is 4x over 9x, which is just 4 over 9. Oh, I'm still highlighting. 4 over 9. ¿Qué pasa?
Can you just show again how you find the ratio to 4x and 9?
Oh, absolutely. So we came up with the scale factor, right? Is 4 over 9. That means we're okay with the scale factor, right? That I got there. That means from 1 to 3, this side here has to have the ratio with this one is 4 to 9. I don't know what the actual number is, but let's look up here. So this has to be 4 to 9, 4x to 9x too, right? So let's just see a real answer. So if this is 4x and this one is 9x, my x must be 2, right? And it's 8 to 18. So this ratio holds for this side. So it'll hold for this side. I don't know what x is. I don't know what length this is. Let's be honest. I don't know what the length is. But I know it's 4, and whatever this x is going to be the same x by 9. And this is going to be a 4 to 9 ratio as well. I'm just putting x's in because I don't actually know the length. And it feels really, really icky as a math person to put 4 and 9 and 4 and 9, even though I know it's not actually length 4 and 9. Does that clear? It's just slightly murky now, just clear as pond scum. Okay. So that should be 4 to 9. C is going to be 1 to 3. Can someone tell you the area ratio? Oh, is it? Oh, I already did 1 to 3. Thank you. That doesn't work. That works. Can someone tell me the ratio Grace, you want to tell me the ratio between 1 and 4, the area ratio,
4x/9.
which equals 4/9? Yeah, nailed it. All right, now we got D. D is 2 to 4, I believe. Mary, can you give me that? It'd be 1 to 1. I mean, realistically, it'd be 4/4 and 9/9, but it would be 1 to 1. Yeah, ends up as being 1/1. Here's where a slight problem occurs, is E. I need to compare 1 to the entire shape. Well, we have the general premise, right, gentlemen?
Yes.
Where I take the top is going to be the triangle ratio, and I'm going to add all the ratios along, and I should have 4 things added up, because I have 4 parts. Here's where it gets a little tricky, though. My 1 to 3 says it's 16/81. This one says it's 4/9. All 3 of these have to have the same starting value in order for me just to have one number on top. Okay? So on this one, I can't put just 16 and I can't put 4 right now because they all have to be the exact same numerator. How can I make all 3 of these have the exact same numerator? Here? Multiply by 4. It still preserves that ratio, right? If I multiply top and bottom by 4, it still preserves that ratio. So if I multiply this by 4 and this by 4, so this really could be my answer. I'm just going to say that right now. This is my answer. I don't have to multiply until that last part. But that's going to equal 16/36. Do the same thing to this guy. Times 4 times 4. That's going to equal 16/36. And the only reason why I did that is so that I had 16 on top all the way across, which tells me on E I can have a 16 on top. Then on bottom I put all of those numbers, 81 plus 36 plus 36, and here's where it gets a little tricky. See how tricky that is?
Sorry.
I think it ran out of juice. It ran out of the proverbial juice. Well, it reboots itself. So right now we have, you should have on your sheet 16/81 plus 36 plus 36, correct?
No.
That is correct.
But there's another number.
There is another number, Gracie.
Plus 16.
Plus, why isn't it 1?
Because it has to be 16.
It has to be 16 to 16, so we'd add a 16. I'm glad you caught that. So we'd have to add a 16 to it. All right, so that E is going to be 16 divided by 81 plus 36 plus 36 plus 16, and that accounts for the whole area.
Mr. Colley. Please go ahead and say
Does that make sense? Are we tracking on those? All right, let's get my computer booted up real quick, and we'll look at a couple other ones. Yeah, I get it. It was out of battery when I didn't notice.
Mr. Daniel, just keep your computer plugged in the whole time.
I try to. I just forget. Because I go between classrooms and
Wait, what's
my
the other
office.
question?
Well, it's just this classroom, but I have to go to my office
Oh.
and drag everything with me. If this is just regular classroom, I'd just stay plugged in all day.
Say, can I have it?
I try. Thank you.
Muscle memory.
That's the truth. All right. Do we have a specific not 22?
I did 21.
And it didn't really math happen.
What? No, because we were supposed to do it.
I know you weren't. Do we have any specific questions while we're just sitting here? Otherwise, I'll just go through the ones I think. So should we just go over 26 and 27 then? Just to make sure we got them? We have no, yes. Okay. Because those can be on the test. Any one that I'm covering today can be on the test. Alright, don't be like, oh, it's super hard, you won't put that on the test. These are all eligible to be on the test. Number 22, I'm not going to put on the test. Okay, number 22, I'm not, even though it's the same idea, even though it's realistically the same kind of process, it just takes a whole bunch of numbers and work. It takes so much time. Okay, 26. 26. Go through our checklist. Similar, same height, same base. Who can tell me which one this is? Similar, same base. Who can raise their hand? Noah, thank you.
Similar.
They're similar. I'm looking for the ratio from 1 to 2, right? So the only thing I can do right now is 1 to that big triangle. So I can go 1 to the big triangle. That's what I'm going to start with. 1 to that big triangle. I'll just put a big triangle there. 1 to big triangle. Well, my scale factor, since they're similar, well, that's got to be easy enough. It just must be 8 to 10 because those are the two numbers. Do you guys not understand? Is that why you're raising your hand? What's up, Mary?
It would be 8/18 because you're doing the whole.
Oh, because it's the whole big triangle. Oh, okay. So my scale factor is actually, my scale factor can't be 8 to 10. It's got to be 8 to 18 because the full length of this triangle is 18. Okay. So then I go to my area. Well, let's just simplify this real quick. So this would be 4 over 9. I want to get my area ratio. My area ratio is achieved by squaring the top and bottom, so that'd be 16 over 81. But that's the area from 1 to the total triangle. I want 1 to 2. I want 1 to 2. So right now I have area 1 to the big triangle, but I want area 1, which is still 16, to something a little less big than the big triangle. Yeah?
81 minus 16 because the 2 is like the big triangle minus the number 1. 'Cause that's
Yeah.
What?
yeah.
Oh.
So what Lauren just said is, so right now I have 16 over the big triangle. What I want to do is I want to have 16 to the big triangle and go ahead and lop this guy off. Right? That gives me 2. I want to lop that off. So I want the whole triangle minus something. So I have the whole triangle on the bottom. I know I have to subtract something away from it. And I want to subtract this small sections ratio. Well, that small sections ratio is 16. So it'd just be 16 over 81 minus 16. Good, bad, somewhere in between.
Great.
Great. I'm just so I get a feeling. Yeah.
Would 28 be one that would be on the test because it was like
Do I have 28?
Oh,
28.
that one.
That one. So that one goes down to the fact that we know this is 30, 60, 90. This is 30, 60, 90. I wouldn't put it on the test. But it is clever in the fact that the one opposite from 30 is s. The one opposite 60 is s square root of 3. So it actually turns out that the ratio between the two is s over s square root of 3, which is just 1 over square root of 3.
Whoa.
I really shortcutted that explanation. So it's not as easy as it sounds, but it just relates to the fact that
1 over 3.
if, what was that?
The answer key said 1 over 3, not square root.
Yeah, because you have to, because
Yeah.
Oh
it's
yeah,
a similar triangle.
Gotcha. I
You
gotcha.
have to do that.
Did you go back to the last slide?
Oh, absolutely. Is this it?
No.
think I lost it.
Do you remember what the?
Oh, here we go. It was just this one. Yeah. Are these making more sense? So your only homework tonight is look over the ones that we did, look over the other ones that were the color drawings, and make sure you can do those and you understand them. All right, fair enough?
Gotcha.
And then tomorrow we'll do the lesson. Have a wonderful